Good morning, good afternoon, good evening, wherever you are in the world. Many thanks for joining this webinar today. I hope it's going to be interesting. I've entitled it, "Are We Slow to Adopt New Technologies?" And I know many of you will not be slow to adopt new technologies, but it's a topic that I'm interested in, and hopefully I'll spark some interest in you and some questions. Before we go into the presentation, can I just make sure that everybody's turned their microphone and cameras off, keep the bandwidth low, and the presentation will run nice and smoothly. So I'm going to start by talking about what I think has been the development generally of fire detection, certainly over the last century and a half. And then I'm not trying to be controversial, but I will suggest a few reasons as to why development and actual fire detection installations don't always keep pace with the technological development that companies, obviously, I'm interested in Securiton's technologies, but generally that we don't necessarily adopt technology as quick as we could. And then I will end my presentation just talking in a bit of detail, not too much, about I've called it what's new, but these are technologies, products that are actually available today, and in some cases have been around for a few years. And actually, in some cases, adoption is huge, but perhaps not everywhere throughout the world. So I hope this will be interesting. It's a little bit different. I'm going to just quickly introduce myself if you don't know me. I'm the marketing director for Securiton International, covering the United Kingdom and Ireland. I have worked for Securiton for nearly 18 months now, after being a long time admirer. I've been in the fire industry over 30 years. And yes, I'm still only 38, which is, a miracle. I'm still a very young man. I've got at least 25, probably more years experience in aspirating smoke detection, but I do have a fairly broad experience of detection technologies of all types. And I've been working in business across Europe, Middle East and beyond for pretty much all of my working life. And my contact details are on the screen now, so if you need to contact me, please do so, and I will redirect you to a colleague if you're in a different part of the world to me. So let's have a look at what I call fire detection development, and in a way this is just meant to be a little bit of fun to get us going. If you think about fire detection, obviously fire has been around for a long time. Man first discovered fire a long time ago, and I think obviously understandably we were slow to develop technologies that would help us counter the threat of fire. So if I look at the pictures that I've got on the screen, on this left hand side we have a fireman. This dates from 1750 apparently. Very official looking chap with a machine of some kind, I think probably with a hand pump and some buckets and some water. We have, in history terms, a relatively recent fire alarm call point. That's one of the earliest ones, the earliest ones that I could find a picture of. We have a very old fire alarm bell from a company called Reliable, that I think were an early innovator, if that's the right word, in America. And at the top right, another view of a fireman with something that looks like it's out of a sort of 1950s sci-fi film, but that was a fireman at some point in history. And then perhaps very unkindly, I've got a picture of a gentleman who has probably an even bigger nose than I have, but that's still often the best way to detect fire. It may not be a considered or approved fire detection technology, but it's amazing how humans and the human nose can assist in that process. I'm joking, of course. We don't rely on humans. We try to rely on the technology these days. A bit more seriously, there's a bit of history here, and obviously, as I said earlier on, I'm based in the UK. In 1902, there was a gentleman by the name of George Andrew Darby, who apparently patented the first automatic fire system here in the UK. In 1930, there was a Swiss physicist who devised an ionization chamber capable of detecting combustible gases. And then there's a gap there of 40 years to 1970 when Securiton first developed an aspirating smoke detection device. And it was just a couple of years afterwards that Donald Steele and Robert Emick from Electro Signal Lab, again in the US, invented the photoelectric optical smoke detector that we're very familiar with today. And I was doing some research trying to work out exactly when the first analog addressable fire system was introduced and installed. I think I can find something going back to 1984, but I think I probably need to do a lot more research. And if anybody's got any evidence of exactly when the first analog addressable system was installed, I'd really appreciate you sharing it, because I'm quite interested in the history here. Kind of closer to home, I'm going to show you a slide here of just our history, Securiton's history in terms of aspirating smoke detection. As I said a moment ago, in 1970 through all of the 70s and 80s, we had our RAS detection technology. But you can see that by the early 2000s, we were starting to reinvent the technology and produce what probably is known better to us totally as aspirating smoke detection. There's a whole variety of developments through the late 90s through the 2000s, and if I stop, let's say here, for example, in 2020, we produced our first kind of harsh detector, aspirating detector, the ASD535HD, moving aspirating into areas that perhaps hitherto it hadn't been seen. And then shortly afterwards, we have the multi-channel ASD, which is very, very clever and very useful in applications where addressability is required. And then going sort of right up to date to late last year was the introduction of the 533-2 that really completes our current portfolio. We have an aspirating detector to suit all sizes of room or building, without wishing to sound too mercenary about it. We've got an aspirating detector to suit all economic requirements. We have a really good range that covers every application. All sizes vary, and also all sizes of wallet. So that was a little bit of a trip down memory lane. What I want to do is maybe talk about the controversial bits. and think about why development and adoption is often slow. Now, these are my ideas, and I'd love at some stage to hear yours, because doubtless you have plenty of thoughts as to why adoption of technology is slow. But let's start with one really important point. Regulation is really important. You know, it's mandatory. We have rules and regulations to comply with. So we always need to make sure that whatever we do, we're in compliance with local regulations and standards. And sometimes it's true that the standards are a bit slow. They lag behind the development of technology. So I fully accept that. What I struggle with is comments that you will sometimes hear, and I know I have more than once or twice, is that people are slow to adopt whatever the technology is because they haven't used it before. I often hear people say that for certain technologies that they deem it to be too expensive for either their needs or their application. And then, as sadly, the comment, "it's too complicated," does appear. And, you know, I'll talk more about each of these in a bit more detail in a second to try to explain how, for example, it's not too complicated. It's just that maybe it hasn't been explained well, or you haven't seen or understood the technology properly. It's also a common comment that we get back about, you know, needing some confidence, that people need to see that if they haven't used the technology, that somebody else has, and that they've had a good experience. And I understand that. I think even in our personal lives, we take recommendations from friends, family, before we adopt new technology or whatever it is. We'll look for a recommendation, a study from somebody we know and trust. I guess I also see quite a lot comments like "it's not specified," which again I understand, and specifications carry a lot of weight of varying sizes throughout the world. But I think it's incumbent upon all of us to work with those responsible for specifications to help them understand technologies that are available that are actually going to make their life and their clients' lives easier. And doubtless, you know, while I've been talking, you've come up with your own ideas, comments as to why things sometimes are slow to develop. And as I say, if you want to share them with me after the presentation, that would be great. I, you know, will intend to build this presentation up a bit and maybe deliver it in a year's time and see how things have developed. If I look at each of those comments that I came up with and then try to answer them for myself. So the comment, I've not used a particular technology X, Y, or Z before. Okay, that's fine, but somebody else will have. And we at Securiton have an extensive library of case studies and design documents to help people understand that they are not the guinea pigs, that the technology has been used, and very successfully, and in full compliance of all regulatory requirements. It's been done before by somebody else. So don't be shy, be confident. And also, I've found throughout my career in business that being an early adopter really helps a business. It's often a great way to improve a company's business and marketability. It actually attracts more business. And then you know, if you haven't used whatever the technology is before, for the right opportunity, offer a trial. And that's something that that we, Securiton, can help with for the right opportunity, trials are good. We have 100% confidence in what we do and in our engineering capability. So, you know, we like to help. The next one, I do understand sometimes cost money is extremely important. However, often when I look at the detail of people's objection based on cost, it turns out not to be 100% true. Safety, anyway, in my opinion, should not be down to cost, but actually it proves not to be the case. And then I am a great believer in not just the price of the equipment on the day it's delivered and installed. I'm thinking about the life cycle of a building over a period of time, and quite often with the right technology, the overall cost over a period of time is much more cost effective than, let's say, older, more traditional products that people will tend to go for to, if you like, keep the safe line. It also, I'm afraid, disconcerts me a little bit when I hear the "it's too complicated" argument. If it's a new technology and people are a little unsure, then we rely on the experts. I think, you know, almost without contradiction, I can say that the support that we offer at Securiton in terms of having dedicated design centres, if you go online or ask me or your local sales manager to give you access to the training modules, they are phenomenal. There is nothing that's not covered in the training slides. There are some fantastic videos. There is literally no excuse to not be able to understand the technology and how it operates, how to set it up, how to commission it, how to maintain it, etc. And then as a final part of our help to you, you know, we have technicians all over the world who are experts in all our technology. And if we get to that stage where we need one of our experts to visit, then we're always happy to help out. The confidence thing, you know, I probably do understand, but I've mentioned it already. We have an extensive library of not just design documentation, so it actually helps you through the cycles of a project, what to consider, the pitfalls that will appear, the ways to mitigate against potential problems. And then we have this extensive library of case studies, people who have already installed the technology in the application that you may have some concerns about. It's been done before and it's been done well. There should be no lack of confidence. This may be the controversial bit a little bit. It's not specified. And I'm reminded of Henry Ford, the innovative car maker in America. His comment, if you do what you've always done, you'll get what you've always got. And I think, to me, that sums it up. We do need to, you know, think a little bit outside the box. And if there are technologies that will actually ultimately make our lives easier and that of our customers and our clients, then it really is incumbent upon all of us to at least take the time to understand the technology and hopefully adopt it. So I'm going to switch direction just a little bit and talk about some of the technology, and I have the word new in inverted commas there. only because this technology exists, and in some cases has existed for some while, but it's perhaps not very well known. It may be that you know of it but have not used it. But what I would urge you to do is to study it, to talk to a sales manager at Securiton, to listen to him or her, to read the case studies, see who has used it, to look at the design guides, understand it, and then make a value judgment. I think you'll be surprised. I'm going to start with a particular favorite of mine, the ADW linear heat detection system. It's an incredibly clever, dare I say it, unique detection product. It operates detecting the pressure in a tube, that it then reflects that in a temperature reading, and we can install the tube in copper, stainless steel, or even Teflon. We can make it highly sensitive. It doesn't have to be, but we can make it highly sensitive. And if in a particular area there is a pressure drop, we will assimilate that as a temperature change. It is a phenomenal detection technology. As I said, I'm not sure there's anything else like it in the world, and it can really solve tricky detection problems. I have a favorite example of my own here. It is installed in a large distillery, a Smirnoff distillery in Italy, using copper tube. But it may not be a distillery that we're looking at. We might be thinking about a transformer, or indeed anything in the food industry, and then changing application completely. I'm looking at car parks or any harsh environments. The fact that we can install it in Teflon steel or copper tube means that once it's installed and set up, there is little or nothing that can actually go wrong with the technology. It has a sensing range of, if I'm just thinking about metal tube, of between -40 and 300. It's IP65, and we also have an ATEX approved version. So it's really good in potentially tricky applications. A different technology, but still line type detection. This is the D-List Listec. Actually, this is a well-known and proven technology that has been used extensively across the world, and I know that in the UK, my own country, used a lot underground, particularly in the tube stations lines in London. It's an unbelievably, again, clever technology. It is addressable linear heat detection, and we can space sensors. You might just be able to pick out, if my mouse is visible, the actual sensors within the cable itself. We can position sensors between 1 and 10 meters along a length of cable. In the Listec, we can actually go up to 3.5 kilometers of tube, which gives us up to 350 sensors along a single line of cable. And the applications here, again, can vary. Again, we might be looking at car parks. I think with the advent, the increase of electric vehicles that we're all seeing to a lesser or greater extent, fires in car parks are becoming an increasing concern and risk. But as I mentioned, with metro stations, metro tunnels, simple road or rail tunnels, it's a great application. I was actually driving through a tunnel under Dublin yesterday. There is, if anybody's been to Ireland, there is a road tunnel that goes underneath the river and crosses the city, just to make your travel a bit quicker. But it's they're incredibly dangerous and tricky environments, tunnels. Obviously there's only really two ends out, the beginning and the end. We need to make sure that we've got detection technology that's providing reliable early detection, and Listec can be great in those environments. It's also actually very useful in things like conveyor belts, particularly for what I'd call relatively harsh environments. It's just a great technology all round. Something else I want to move on, different, flame detection, perhaps underused, but we have a range of flame detectors at Securiton, offering UV and IR detection. We have a device that can work in EX zones, standard flame detection zones, and then zone 2 or zone 22 flame detection. Really good, robust technology, and at I might add a reasonable price, to be honest. It's very flexible technology. We can connect it. It's open protocol. We can connect it to any fire system that is in operation. Flame detection is brilliant for places like fuel tanks, fuel storage, perhaps waste processing is a good application for flame detection. And a particular favorite of mine is aircraft hangars. Aircraft hangars are massive cavernous spaces. Flame detection can quite often be the best and most appropriate technology. Moving on just a little bit, although relatively similar, we have an absolutely fantastic 8X beam detector, the Ilia 8X. It's a infrared beam detector. Again, it can be installed in zones 1 to 2, 21 or 22, operating up to a distance of 120 meters. Really clever, robust technology with a low-level controller that we can connect. Ilia Pro 8X detectors too. Really fabulous solution. Whether we're looking at recycling plants or fuel processing, refining areas, really any 8X environment, the 8X Ilia can be the answer. We've got clean contacts for output, any interface on any alarm protocol. We've got adjustable sensitivity thresholds, which can be selectable from the controller, which one would assume would be at a low-level access point. We can add delays in for up to 4 minutes to allow investigation. Really clever, reliable, robust technology. My kind of last new technology is probably the newest of the lot. Many of us will have seen the dramatic increase in the use of lithium-ion batteries in all sorts of applications, all sorts of technology. We're kind of very used to them in things like mobile phones and laptops, but we're now starting to see them obviously in electric vehicles. We're seeing them in all sorts of devices, in our homes, in our workspaces. And lithium-ion batteries are great. They're going to be around with us for a long time, but they can be, in certain circumstances, a bit problematic. And the detection of things going wrong with lithium-ion batteries is a little bit different. It's a little bit different than smoke detection or heat detection. Yes, smoke will be generated at some point, heat will be generated at some point, but quite often when a lithium-ion battery is beginning to fail, it will vent off what are called VOC, volatile organic compound gases, things like diethyl carbonate, dimethyl carbonate, and we have a technology to help with that. So we have VOC and also flammable gas detectors. You can see a little schematic on the screen here with a room, an area, let's call it a data center, where we've got a daisy chain of sensors, both VOC and then flammable gas detectors within the space to provide an earlier than any smoke detection, even than a sophisticated aspirating detection system like Securiton's ASD, an early detection of potential problems. And I think perhaps the biggest risks, I think, to us really as a society from these lithium batteries, and sadly we've seen some instances across the world where problems have been caused by batteries in the UPS in data centers or in energy storage containers, BESS. And there's a way to prevent or at least mitigate against major catastrophe in these areas. Using VOC and or flammable gas detectors will really help. It gives the earliest possible warning of any battery abuse, failure. Our sensors are calibration free. We have options, ranges to detect H2, flammable and volatile organic compound gases, as I mentioned, and our devices are tested to UL and also approved to something called ETL, which is another underwriter laboratories UL 2075 specification. It's fantastic technology. If you haven't explored it yet, please make sure you do so with either myself or Zach, who's also on the call, or a local sales manager. On that note, I'm going to say thank you for listening. I hope you found it interesting. I do just want to say a quick reminder to make sure that you follow us. Securiton's got a great channel on LinkedIn, Instagram, and TikTok. If you're unsure how and where to follow us, again, just contact us, and we'll be delighted to help you out. So I'm going to say thank you. I'm just going to have a small sip of water for a second and see if Zach has any questions for us.
Hello, Justin. Yeah, while you take the sip of water, I'm preparing the questions that I've got. So the first question is, do you have EX-ASD units?
Yeah, good question, because I should have mentioned it. I talked a little bit about effectively EX, ATEX detection in terms of flame detection and the ILIA beam ATEX, but we have an aspirating unit that is also suitable for use in EX areas. We have approved flame arresters, and we use the harsh detection aspirating detector. So that is also a technology aspirating that we can use in ATEX environments.
The next question is, how do I get access to the training modules?
I should have put a link in the training session in this presentation, but you can actually just find the link on the Securiton website, or by all means just contact us and we'll direct you. But it's you sign up for it one time only. Sign up on the Securiton website, and all the training modules are there.
And the next question is, what is the maximum length of the ADW tube?
Okay, so that varies depending on which tube that we're using. So if it's the Teflon tube, we are limited to a maximum of 140 meters. But if we're using the steel, so the or copper, so metal, we can go up to 200 meters.
Next question, so many options, how do I know what's best to use?
Yeah, good question. That's often the thing with choices. When you have too many choices, it can often be a little bit problematic. Well, we'd obviously be delighted to help you to advise what we think is the best technology for the risk or the application that you have. I forgot to check, so I'm asking a question back to you, Zach. But we had something called the selector, or the product selector, that one of our colleagues was working on, Marcus Muller. Is that still in operation? Do you know? I haven't checked. Forgive me.
No, it's in operation, so that can be found on the partner data. So if anybody wants to have an access to that, please contact your sales manager, and he will show you where it is. Or we could send you a link after the webinar as a follow-up.
Yeah, it's a great piece of kit, because you're able to input basic data from your risk and things you're worried about, your concerns, and it then will actually point you to the suggested answer, suggested technology, or maybe give you a couple of options. So it's really worth exploring that. Thank you, Zach.
Next question, how ATEX Elia Pro beams can I connect to a controller? So how many?
I neglected to talk about that when I talked about the controller. So we can connect up to 8 Elia Pro beams to one controller, which will cover a huge area, and it's very nice to be able to access them, program them, control them from a low level.
Next question, can I connect the gas sensor systems directly to an ASD?
It is a good question, but no, not directly. They operate independently, but that they can work in slight conjunction, but they're not connected to the ASD. They're normally connected to either the fire alarm control panel or perhaps the BMS, but the detection of VOCs, flammable gases, is separate to smoke detection, even if it's sophisticated aspirating smoke detection.
Justin, you were earlier speaking about this addressable linear heat systems, the ListTech. Is it really installed in solar panels?
It is, yeah, and I laugh when I say that, because I'm looking at one of my neighbour's houses at the moment where I can see their solar panels, and I know he hasn't got ListTech installed in that. It may be a step too far for domestic premises, but who knows? There are plenty of examples of big commercial solar installations where ListTech is installed within the solar panel array installation, and you will see in the press, unfortunately, fairly regularly, where something has gone wrong with a solar panel installation somewhere and caused a fire and probably a lot of damage. We can prevent that by using ListTech. It really is a perfect technology for that risk. So if you're unaware of it, contact us and certainly get a case study so you can see that it has been done before, and we have confidence, and don't be afraid.
And the last question, Justin, is I have read a lot about transformer fires. Which system is designed for that application? Recently, there was in the news some transformer got fired London Heathrow, and we hear a lot of things, transformers getting burned and so on. So which system at Securiton is designed for such applications?
That's a brilliant question. I don't know whether anybody actually was impacted personally by the shutdown at Heathrow. And it's not just Heathrow, it does happen in other places. If transformers have a problem and fire occurs, it can cause real disruption. And it's an area I think we all need to be aware of and use the ADW. It's a fantastic technology for that risk. And it will not surprise any of you that we have installed many ADW in many transformers across the world. And we have case studies that we'd be delighted to share with you and ask you to share with anybody in that industry, because we can help. And I dread to think about the cost incurred from the recent events at Heathrow, shutting down a major international airport for that length of time, and the knock-on costs of people not being able to travel for business or holidays, personal visits. It's not fair, and we can prevent it. So please, if you're anywhere near the transformer business, contact us and get some ADW information and the case studies. Great question.
Thank you, Justin, for answering those questions, and thank you for the webinar. It was great.